In this factoring methods video, we will practice factoring perfect square trinomials. These are college algebra level problems. When you have a trinomial, the first thing you want to do after factoring out the GCF is to consider whether you have a perfect square trinomial. Perfect square trinomials factor as binomials squared. The two formulas you can think of are a plus b squared, which is a squared plus 2ab plus b squared, and a minus b squared, which is a squared minus 2ab plus b squared. 9x squared plus 42x plus 49 may be a perfect square trinomial because the first and the last terms are perfect squares and the middle is even. If it is a perfect square trinomial, it will factor as the same thing twice. So we're going to try 3x plus 7 times 3x plus 7. Now we know that 3x times 3x gives us 9x squared, and we know that 7 times 7 gives us 49. So we need to check the middle. The outer product is 21x. The inner product is also 21x. These add up to 42x. And so this is the correct factoring for 9x squared plus 42x plus 49. We're going to write that as 3x plus 7 squared. In example 2, again we have perfect squares for the first and the last terms. 25x squared is perfect square, 81 is a perfect square. They both also need to be positive for this to work. And the middle, negative 90, is even. So this could be a perfect square trinomial. If it is, it'll factor as 5x minus 9 times 5x minus 9. Again, we know that the 5x times the 5x will give us 25x squared, and we know that the negative 9 times the negative 9 will give us positive 81. So we're going to check the outer and inner products to make sure that they add up to negative 90x. Negative 9 times 5x is negative 45x, and 5x times negative 9 is negative 45x. These do add up to the correct middle term, negative 90x. In example 3, we again have a perfect square for the first term and for the last, and an even in the middle. But if this is a perfect square trinomial, it will factor as 2x minus 1 times 2x minus 1. This time this doesn't work. If you check the middle products, negative 2x and negative 2x add up to negative 4x. And in fact, this particular trinomial doesn't factor at all. And I just realized I did not rewrite example 2 as 5x minus 9 squared. That's the best way to write the factoring for that. Okay, and number 4 is definitely not a perfect square trinomial. First of all, you've got a negative on the end. Your first and your last terms have to be perfect squares, but they also have to be positive. If you tried to factor this as a perfect square trinomial, 2x minus 1, 2x minus 1, it wouldn't work. Use FOIL and you'll see why. You get 4x squared minus 4x plus 1, so that doesn't work. Some students might be thinking, oh, 2x minus 1, 2x plus 1, but that doesn't work either. That's a difference of squares pattern, and that actually gives us a binomial, 4x squared minus 1. And in fact, this trinomial, 4x squared minus 4x minus 1, doesn't factor.